Hello everyone. Today we are going to go through modified Kaprekar numbers, which is a problem on the implementation section of algorithm on HackerRank. So without wasting time, let us have a look on the problem statement. So before getting into the deep of the problem, if you're not subscribed to the channel, I will encourage you to subscribe. Do not miss what we are doing here regarding problem solving, algorithm, and data structure. So here's the problem statement. We have a number n, and then we have a digit that represents the number of digits of that number. And then you are supposed to perform an operation, which is the follow. You're supposed to square n, like you see here. You have n square, and then you're supposed to take the last digit of n plus the rest of the digit, and then you found out if that sum is equal to n. This is one example. So you have n 5, d equal to 1, the number of digits of n, and then you square n, which is 25. Now the number of digits of n is 1, so you need to take the last one number, which is actually 5 here, and then you need to take 5 plus 2, because the rest of the square number is actually 2. 5 plus 2, which will give you 7, and 7 is actually different from 5. So this is not a Kaprekar number. Here's another example which is working. So we have n equal to 9. N square is equal to 81. The size of n is equal to 1. So if you want to split this into two numbers, you have the last one digit, which is 1, and then the rest is 8. So you have 8 plus 1, which is 9, which is equal to the original number. So 9 is a Kaprekar number. Here's another example with a bit of the long operation, 45. I hope you have seen. So you can see we have 45 square is equal to 2025, and then 45 has 2 digits. So the last 2 digits of the square number is actually 25, and then so we are going to make 25 plus 20. 25 plus 20 is give you again 45. So 45 is a Kaprekar number. So given this example, how are we going to solve this? So to solve this, we are going to implement exactly what we just described as approach. So it will look like this. We will have our, this is an example, we have our value. You will square the element. We will count the number of digits of the element. We apply a function to count the number of digits in the element we receive as input. And then the result now, the first thing we are going to do is to remove the last d digit. In this case, the d is actually 2. So to remove the last d digit in this number, we are going to apply something like a modulo operator. So the modulo operator of 10 power of 2. So this is 100 because 100 is 10 power of 2. So if it was 3 here, we would have 10 power of 3 here. So this operation will help us to have the last digit of the square. And then once we have it, you will now compute the number of digits in the square operation. And then we are going to remove the number of digits in the number of digits of the input that we receive. 4 times 2, that will give you 2. These 2 represent now the remaining numbers. So, and then you do agree with me that if you remove this, the remaining number is 2 operation. And then what are we going to do with these 2? We are going to convert this into string, and then we are going to take the 2 or the rest first digit in this case the two first digit, this is actually 20, and then we are going to add those 22 to the result. So this is actually how our function compute payback will look like. So let us associate that with the rest of the code and see what it look like. So the first thing is that we are going to have a boolean saying that okay, the valid range is false first of all, and then at the end, if we don't have a valid range, if the valid range is still false, then we are going to return invalid range. We are going to have a for loop to move from the two, like from P to Q. So we are moving from the start to the end. So this is here, this is the element. And then for each of the element, we are going to compute get sum, which is the function that will implement the logic that I just mentioned here. And then if at the end, the result of this function is actually equal to the element that has been taken as input, then it is a Kaprekar number. So we see out here, and the important, we put the valid range to be true so that we don't have to output this. So if with this for loop we don't find ourselves getting into this condition, so we are going to have this. So what would the Kaprekar function look like? It will just be the exact implementation of what I just said here. So you compute the square, you make use of this operator to get the number of digits of the input that you receive, and then now the result, you initiate the result with the modulo operator that I just mentioned here. So the modulo operator of 10 power of digit. So in this case, it will be 100. And then now you compute the rest. You now to find the rest of the number of digits in the result, the number of digits in the result that you need to take at the front. And then important, you need to check if the rest is actually greater than 0, because in some scenario, like for instance, if you take 1, the number of digits, when you will take the first start, that means the first 1 digit, the rest is actually 0. So if you try to perform this operation, you have index out of n. So you need to check that the rest is actually greater than 0. Now if it's greater than 0, you convert the square root into a string. Now you take a substring from 0 to rest, and then you return the int value of your result. Basically, when you have to convert this into int, you return directly your result. So this is an approach of solving this. Let us run and see what it did. You have everything ready. Let us submit. So you have everything. You may be curious about something like, okay, hey, here you are taking get sum, you are taking I, which is actually an int here. Why do we have to put it long here? So if you put it int here, you will have one case which is failing. And then why is that case failing? The case is failing, like you have this one failing, because this is actually an int. And then when you perform this long operation, square root take a times a. Indeed, you say, okay, this one is long, but this operation is going to be performed, and the result is going to be affected here. And then int times int will give you an int, and then during the affectation is going to be cast into long, but it's already going to be out of range. So this result will not be the real result of a times a. That's why you need to have a long way in order for you to do not miss this result. So this is my approach of solving this. I'll be doing very. Feel free to leave me a comment in the comment section. I'll be really happy to interact with you regarding this. Stay tuned for the next video. Keep learning. Ciao.